Well, I'm joined by Adam today. Adam runs our integrating engineering staff. He's responsible for deploying all of our engineers out in the field to help you on startups with brand new stores or remodels. I'm gonna have to get used to this microphone. I'm not used to using a microphone. My name is Charlie. I've been with Sporlan for 34 years. I'm an old valve guy, but when we purchased Microthermo 14, 15 years ago, I immediately took the transfer over because really, as Rusty was saying in the class before this, electronics is the way this industry has got to go. You know, I'm inspired that so many people want to learn about CO2. They want to learn about the different control methodologies. So I thank you for attending the conference, and I thank you for attending this class on Microthermo. Microthermo's been around in Canada for about 30 years. But I would say the major push that we put on North America is about in the last 15, 16 years. So I appreciate you taking the time to come to this class to learn more about Microthermo. I want to make this interactive. I do have a lot of slides, so I'm going to move rather quickly, but please stop me if I am not clear or if you have a question. If I don't know the answer, I'll get you the answer, or I'll ask for Adam to help me, just to make sure we don't leave you hanging if you've got a question. I want to have at least 20, 25 minutes at the end. My plan is to log on to a live CO2 site, show you how to navigate, show you where the tools are, show you some helpful hints of how to navigate Microthermo more efficiently. Because with anything you do, if you don't do it regularly, certainly when you're in a class like this, there's only so much you can retain. So learning by doing is a good thing. So that's why I want to get to the site. So what is Micro Thermo Alliance? Micro Thermo Alliance is a front-end control platform. Okay? It's state-of-the-art software platform. Like others, we control, we monitor, we gather information, we have graphing capabilities, and we hold a lot of data. But what I want to leave you with today is that we are a management tool. What I want you to get out of this is what are the tools to help you solve a problem, whether you're at the store or whether you're logging in remotely, to how to use Microthermo more efficiently and use your time more efficiently and more effectively. So that's really what I'm going to try to focus on. I'm going to tell you what we do and how we do it, but I want to spend time on showing you the tools that we have on board. So first of all, we use a Windows format. And the reason we chose to do that, because whatever device we're using today, whether it's an Apple device, a Google device, an Android device, it's all about Windows. So if you know how to point, click, drag, drop, cut, paste, select, zoom, you already know how to navigate through Microthermo. You're just bouncing from window to window to window. So your basic view is a floor plan view, and it's comprehensive. And what it's meant to do is cut interrogation time down. We want you to be able to view the health of a system at a glance, not have to dive deep if you don't need to. If you look at it and you see that all of the nodes are green, then you don't have to go any further. That means everything is operating perfectly, and I'll dwell on that a little bit more as we get a few more slides in. So you get a comprehensive Windows-style view. You got your menu tabs across the top that lets you get to the different points in the system. All of the icons are color-coded, and there's the zoom-in feature, which I'll show you in real time, that allows you to zoom in and dig deeper into the problem. Now, up front, I want to say, for clarity purposes, I will use the term node. When I use the term node, it can mean two things. There's the virtual icon that you'll see on the screen. That is the representation of the smart node. When I use the term node, I might also mean the actual hardware itself, okay? These are microcomputers. They're self self-operating. Once we integrate the store with you, they are self-operating smart nodes. And so when I use the term, I could be referring to the icon on the view, or I could be referring to the hardware itself, okay? So, like I said, you can go from window to window to window. So right here, that's the defrost window, 24/7, 365. You can view the schedule, you can change the schedule, you can change the parameters of the schedule in that window. For those of you who've been doing Microthermo for a while, that's the classic 500 view of the rack. It's more of a tabular style. And then we have the 700 view. That's more of a virtual style. You actually see a physical representation of how the rack is installed in the mechanical room or the penthouse. And then all of your points, your information, your pressures and temperatures are all live. Hope to have enough time to talk about this. This is the MPC. It's the programming tool. We also have an eMPC and a brand new line, which is going to be called the UC700. But what it allows you to do is it allows you to get inside of a node, whether it's the 500 node or the 700 node, the MPC or eMPC. And for lack of a better term, it allows you to jailbreak it. And allows you to write your own custom programming. But the cool thing is you don't have to know C++ to do it. If you can think it, if you could sketch it on a pad, when you get very good at Microthermo, all you have to do is pull down the icons from the programming palette on the top. What do I need? A calculation function. What do I need? A PID. I have an input. The input is going where? To a timer. The timer is going where? To a sequence. That's going to a calculation block. That's going to a relay, right? So if you can think it, if you can write it on a pad, you can virtually program any one of our nodes, even the old school 500 nodes, you can do that. And then lastly, that window there, that's a back-of-rack leak detector. If you order any device made anywhere in the world, and you order it echelon enabled, whether it's a drive, leak detector, if it's the true echelon, that means you can integrate it, view it, and operate it right through the front end of Microthermo. No motherboard, no daughter board, no license. When you say it's real echelon, everything has to work together, okay? So, bottom line, we do supermarkets, but we go beyond supermarkets. We do supermarkets, industrial, commercial, and we can take whatever the facility is. All we ask is that your architect or engineer sends us DWGs of the different views that you want to appear on the screen. You could have a view for refrigeration, rack A, rack B, rack C. You could have a view for the rooftop units. You could have a view for the chiller skids. Just get us the DWGs and we will convert them for you, and you'll have custom virtual views of every aspect in the system. And we're agnostic. If you want to use competitive valves, not a problem for us. If you want to use drives made by another company, not a problem. It doesn't matter to Microthermo. Our theory is to be completely open. We'll work with anyone, but the only catch is it's got to have an echelon chip in it so we can integrate it directly into the platform, okay? So when we designed Microthermo almost 30 years ago, what we tried to do was think about, okay, who's got to touch Microthermo? What would an engineer want? What would an installation contractor want? What would a service contractor want? How about somebody in food quality? How about somebody in the retail office? So long story short, we tried to think of anybody that would touch Micro Thermo Alliance, okay, and put something of value in that platform. Again, to make it a management tool, So what do? Facility control. Supermarkets is our main sandbox. We have well over 300 CO2 installations in North America, probably more than that now. We do frozen refrigerated warehouses, ice skating rinks, marine refrigeration, food processing and prep facilities, ice cream and dairy plants, pharmaceutical process and storage, even Maersk and Sealand refrigeration systems for ships at sea. We've done that too. So if you have an application beyond supermarkets, don't be afraid to contact Adam or myself, and we can give you a solution for that facility management and control. So what are the goals and needs that your customer might have? Well, they want to reduce food loss and improve food quality, extend product shelf life, optimize the temperature control, not just for the product, but for the environment that it's in. Reduce service costs, reduce energy costs, reduce management costs, reduce facility costs. Bottom line, increase profitability. Now, how about for you guys as technicians? Okay, same thing. Your goals and needs, you want real-time smart alarm notification. You can get those either by text message or email, okay? If you're passing through a VPN or VNC, you'll probably have to work with the end user's IT department to make sure that we can pass that information to you. But if you get a text message, it'll be a smart message. It'll say store 832, dairy cooler, incomplete defrost, door ajar, and it'll tell you the time the alarm started. So you'll get a smart, specific alarm, either by text message or by email. But again, the end user's got to allow us to pass that through their system. Technician accountability, not that we want to be the big brother, but we do keep history for 5 years. It's a rolling history, so the really old stuff falls off as we add the new stuff on. But the reason everybody should have their individual username and password is we want you to be able to look at the history of the store when you get called in the middle of the night and see what all of the guys who were there before you did, before you dive in head first and try to solve the problem. Remote graphing and analysis, the 5-year history I told you about. Also from your phone or tablet, anything you can do in the store, you can do on your phone, or you can do on your desktop, or you can do on your tablet, okay? There's no difference in the iteration of the front end of Alliance. So whatever you see in the store, that's exactly what you're going to see on your remote device. We give you an electronic service log, so it's live and it's virtual. It's not the oil-soaked loose leaf pad in the mechanical room. A lot of our end users are requiring that all technicians use the electronic service log, not just for the stuff that you've done on the refrigeration system, but anything that you've done within the envelope of their store. And it gives you visibility. Before you have to roll a truck, you can pop that log up and see, again, what did the technician do by his log entries. I'm going to talk about the alarm triage report. It's actually called the statistics report. Again, all of these tools are meant to reduce labor, reduce service, reduce energy costs, reduce your management costs, and for you or your company to increase profitability. So Microthermo is graphical user interface, okay? Anywhere you need to go in this system, you're just bouncing from window to window to window. So here's the main landing view again. And you can get to anywhere you want from this window. So across the top, you have a menu bar. And then here's the alarm list that I was talking about, the 5 W's, who, why, what, when, where, okay, of any alarm, whether low, medium, high, or notification will be populated at the top. And then your subsystems drop down on the left-hand side. So you could have refrigeration, HVAC, lighting, security, however many subsystems are tied in through Microthermo. In the middle are your permission modes. There are 3 basic modes: configuration, maintenance, and overview. Overview, we usually leave for store personnel. It's pretty much look but don't touch. A lot of times, though, the technicians do give the ability of the store to acknowledge an alarm. I think that makes sense. Maintenance is what about 95% of the technicians would have. And when you get configuration authority, what happens is the actual programming palette shows up. And check it out. If all of a sudden they say, we just want to simply drop 2 more cases in the store, no big deal, even though the store is already stopped and running. You actually, if you have configuration, you can add a case controller. You grab the case controller icon, you drop it onto the floor plan, and then you just start programming it, putting in the set points and whatnot. It's that easy when you have configuration view, okay? And again, you don't need to write code. It's all done graphically and it's all done virtually, okay? The reason I have the stoplight, I talked about diagnosis at a glance. Red is good, excuse me, red is bad. That means you've got something that you've got to attend to immediately. Yellow is caution, and green is good. So when you scan a floor plan, here's what you should look for. Look for the system eyeball, that should be a green circle. Look for the store view, that should be a green circle. And then quickly scan the floor plan. You see nothing but green dots. That means every set point, every superheat set point, every temperature set point, everything is perfect. Nothing is out of line. You don't have to look any further. You can move on to your next task. Everything is working properly. Now, beyond those three colors of red, yellow, and green, we also have orange. If you see an orange halo around one of the virtual icons, that means that fixture or device is right now in defrost. If you see something in bright blue or teal, that means that fixture is in override. We chose that color because we want it to stand out from the floor plan so you don't forget that you left a fan permanently on or a fan permanently off, or you overrode the EEV fully open or fully closed. If you see any of those dots when you get to the store are white, that means the job has not been finished. That means that node is not fully commissioned and integrated into the system, and action needs to be taken. And finally, if the store has been operating for a while, if any of those nodes turn black, that means we've lost those nodes from the network. You're going to start getting an alarm, node offline, node offline, node offline, but you'll see it virtually even before you might get your first text message or email. In case you do have technicians that are colorblind, we took that into consideration. So if they can't see the colors, they can look at shapes. So if they see circles, that's green, everything's good to go. If they see a yellow diamond, or they don't see yellow, but they see the shape of a diamond, that means caution. Action needs to be taken. And finally, if the icon is a square, that means that they have an active alarm. So either by color or by shape of the icon, it tells you whether or not you have a problem. Now, I want to mention with Microthermo, we might be different than other modalities out there. Alarms do not go away by themselves. It takes a human to turn the alarm off, what we call acknowledging, okay? We do that because we want it in history. We want the alarm acknowledged. We don't want it to go away by itself. We want a human to take action and put a note into the computer. What did they do to take care of this alarm? Now, sometimes it could be simply you acknowledge the alarm and you just put a quick sentence, we'll be at the store in 2 hours to take care of this. That way the store manager sees the alarm is acknowledged and sees the history that you've been in there, you have acknowledged the problem, and you're on the way. So it doesn't necessarily always mean that you solve the problem, but at least it can give the manager of the store the idea that you've acknowledged it, okay, and you're on your way. The other thing in Microthermo, we have recall, the yellow diamond. Let's do something simple. Let's just say it's the holding freezer. Somebody left the door open for 45 minutes and it's triggered an alarm. Okay, the manager says, hey, Joe Smith, go close the door. He acknowledges the alarm in the office because he gave somebody, a job to do that. But a truck comes in and he forgets to close the door and he starts unloading the truck. Now, even though that alarm is acknowledged, it's going to start counting down. Okay? And if that door remains open and never goes closed, then we're going to trip the recall period and we're going to send a new alarm out saying that the door is left open. That would be the same thing if we get a low superheat alarm, if we get a bad temperature alarm. The same theory of a recall time is there also. So there's your initial alarm trigger, there's your recall time, all right? And you have to acknowledge alarms. They do not go away. So let's take a look about alarm acknowledgement. When you see an alarm, you'll see it in a few places. Depending upon the system that it's occurred, you'll get a red square. This happens to be a refrigeration alarm. If it's active and unacknowledged, it'll be at the top of the list. It'll tell you whether it's a high, medium, or low priority and what system it's coming from, okay? And then it aggregates it up here. Do you have one alarm? Do you have two alarms? Do you have three alarms, etc.? And if the integrator has put the alarm node on the landing page, the alarm node will be also in red. And then finally, of course, you can see the fixture itself is in red. So simply what you want to do is put your cursor over that icon, click, okay, you drill down, and that's going to zoom in, the feature that I told you before. When you zoom in Microthermo, you will see a picture that is descriptive of the case itself. Is it a beer cooler? Is it an ice cream case? Is it multi-deck deli? Is it fresh meat? That'll be on there. The current real-time temperature will be on there. And if you hover the cursor over there, a pop-up window will come up, and the case serial number, if you put it in there, or the circuit identification will be in there, and the rest of the information for that node will be in that pop-up window, okay? So all of those things happen when you zoom in. So now you want to go even further, you click on it again, and you zoom directly in, it'll open what we call the process window. Now, all of our nodes have process windows. Well, I don't know why it's doing that. Thank you. And this is just a simple temperature sensor process window. And you can see what happened when you're good to go. Okay, the temperature started rising. And right in this period here was long enough to trip the alarm. And then the actual graph itself goes red. If it's a high priority alarm, the bells and whistles in the store might go off. We'll send a text message or an email out. And to acknowledge it, you simply click onto the acknowledge button in that active window. Your name will be there because you're already logged into the system. You put your password in and then put 1 or 2 sentences. You don't have to write War and Peace. Just for the next guy that's coming along, put the action that you took to solve the alarm. Click acknowledge, and then the alarm goes away, okay? And that history is retained in there for, could be up to a full 5.5 years until it becomes so old it drops off at the end and we put new history on, okay? So we say with Micro Thermo Alliance, it's the power of information. So it's intelligent distributed control. As I said earlier, think of these nodes as microcomputers. And we distribute these all throughout the store or the facility. History is retained for up to 5 years. As I said, we've done over 300 CO2 stores in North America. And again, we integrate all the subsystems, whether it's on Microthermo or it's a third party that's in the store. If it's Echelon enabled, we can aggregate it and you can have full access right through the front end. Colorful, visual, so that you can manage at a glance, and completely customizable. So what do I mean by distributed? Okay, other modalities, you have a store controller. That store controller, because it's got so much responsibility, usually has limited history. That's just a function of disk space that's available. But what we do is we put a Windows 10 data logger, the guys call it. It's actually an industrial computer, okay? And it's an industrial computer because it's military spec, redundant hard drive, and all of the horsepower of the Windows platform that's on board is focused to run Microthermo only. No bloatware for social media, for gaming, none of that stuff is on there. That is the HMI, the human-machine interface. That allows you, the human, to get inside of the network and see what's going on and have access virtually to the physical hardware in case you have to troubleshoot, change a set point or whatnot. So I'm showing the Microthermo 700 platform, but what we would do in the instance of a case controller, the case controllers, okay, would be individually top of the case, back of the case, in the kick plate, whatever imaginative place the manufacturer can think of putting them. And then we'll have a node train like this back on the rack for the rack control. And then for the gas cooler or condenser, generally they will also be at the rack for safety purposes. HVAC systems, many times they will be up in the rooftop. Seasons 4 actually purchases the Microthermo nodes and installs them directly in their HVAC units when you say it's going to be a Microthermo store. Or I've done stores with York, Train, Aon, just to name a few. I'm probably leaving some off. All you have to do is order the HVAC unit Echelon enabled, and then you'll be able to integrate it, view it, and control it right through the Microthermo front end. Adam, I don't know about the CoolJet. I've not done any stores with them.
Not that I'm aware of.
Not that I'm aware of. I can get back to you on that, Brett. Now, just for clarity, there's the front end and the back end. The back end is the Windows 10 industrial computer. That's just like the operating system on a laptop. That's the back end. The front end is the Microthermo platform itself. Obviously, they're running simultaneously, so I just want to make sure I was clear on that. So the back end is the Windows 10 operating platform. The front end is the Microthermo control program. So we take the intelligence and we spread it through the system, and all of these nodes are allowed to talk with each other and share information with each other. Let's just say, even if I'm not doing the HVAC in the store, I have a 722 brain and a 716 UI, and I'm taking the temperature, relative humidity, and any other thing that has to do with the ambient, the envelope of the building, even outside temperature, outside humidity. If I give it to this set of nodes, it's on the network. If I want my case controller to be even smarter than it is, I can tell it, hey, August and high humidity, the store is going to be different than it is in the middle of January when things are colder and drier. You can tell the case controller to listen to the ambient conditions so that it can control tighter. You can tell it to listen to what the drop lake temperature and the drop lake pressure is so that you can make the EEV smarter than it is already. So all of the information that is on the network can be shared equally from one node to the other to help it do its job better, all right? So with facility management, we say if you don't see it, if you don't measure it, if you don't analyze it, then you truly cannot manage it. So now let me get to some of the onboard tools and reports. Before I get into the tools and reports, any questions so far? Because I'm trying to move through this rapidly. Anything? Yes, sir.
Sharing information from one node to the other, does it go through global like on other Emerson projects?
What will they call it global? That terminology is the same. We call it bindings, technically. That's what we use it, bindings. But again, if it is a data point, if it's a superheat, if it's a pressure, if it's on the system, any node could be told, listen to this input. It's important to you, okay? Or we could tell it not to listen to it, you know, if we don't want too much information. So if it's on the network, it's shareable to any node that's on there. So the first report I want to tell you about is the system log. What you would do is you would minimize the front end. You know how to minimize a screen, right, in Windows, that little dash, all right? Minimize that. You're going to see the desktop now. Look for the red cross on the screen, the red cross icon. That's the system log. Open it up. It's going to tell you anything and everything you need to know about the operating system. Was there a power failure? Is there a bug in the system? Who logged in when they logged in? Was there a missed defrost? Was there a malfunction in the software? All of that is going to be found in the system log. Again, you minimize the front end window, you go to the desktop, you look for the icon that's a red cross, and then the system log is there. And you can completely interrogate that. And anywhere all the way up to 5 years of information on the health of the operating system is there. Okay? And with any of our windows, I'll say this now so I don't have to repeat it. You always get a from and to, all right? So if you want to look at it for a day, a week, a month, a year, or 3 years, all you have to do is fill in that data, and then it'll size the report for you depending upon how much data you want to pull. And generally, some users do have hard printers wired up, but mostly you just print it to the screen and interrogate it right from the screen. So that's the system log. This is changes made by users. There, you see up here, you have events and reports. What this does is it lists anybody who's done anything to the system. So some of you might have met Evan. He was one of our technicians before he started his own company. But in this particular store on May 13th, 2018, he was working on B number 1, 722F. The active defrost duration was changed from 44 minutes to 55 minutes. So all of that is in there. When you go into Microthermo, you leave your thumbprints and you leave your footprints. Again, not that we want to be Big Brother, but we want to help you see what happened to the store before you got there. So that's changes made by users. Another report is acknowledged events. What this does, as old as the store is, it could be 5.5 years of history. Any event, whether it's an active alarm or simply a notification, all of that is stored in there. It will tell you how severe was the priority, the date and time, what source it came from, a complete description of the event, who acknowledged it, what date and time, and what subsystem it came from. Again, you could do it for a day, a week, a month, or year. Question?
Can you boil that down to be like, let's say I'm looking for B12 only?
Yes, yeah, that's a great question. You can boil that down. I cut the window down. Not only that, but you can actually look for a particular user. Let's say you have a brand new technician that just started and you want to see what changes they've made while they'll be out in the field. You could actually check it by the user, you could check it by the subsystem, or you could check it by the device. So yeah, you can custom tailor the reports. Okay, so just look for the windows at the bottom, look for the windows at the top, and the reports are workable so that you could do that. All right, so acknowledged events. Now, the report that I like to use is acknowledged event statistics, all right? What this does, instead of trying to find a needle in the haystack, this aggregates all of these events, and it'll group it for you. It'll group it into sensor alarms, it'll group it into object alarms, HVAC alarms, et cetera, et cetera. So what this does is it creates a report, and instead of you trying to look for something and hope that you find it, it will jump out. The bad actors will jump out. You might have to squint, but look at this report real quick. What are the 2 bad actors in this particular store? Yeah. It's the freezer and the cooler. Okay, so just look, let's look at the grocery door ajar. 59 events for 57 hours. That never happens, right? Here's dairy cooler ajar, 47 events, no recalls for a total of 46 alarms. But check it out. What happened when the door was left ajar all that time? Okay, without being acknowledged, we started getting superheat problems. We started getting more superheat problems. We started getting rack emergency shutoff. What probably happened? The coil bunkered up, right? It started flooding right through and right back to the rack, and it knocked the rack offline. Right? So again, that's what this report is helpful to do. So you don't have to go through that list of pages and pages. You can find this right away, and believe me, the bad actors will stand out, okay? If you and I have done our work properly, and you look at a store for 60 days, 90 days, 120 days, maybe you should see a third of a page or a half a page. If you get 3, 4, 5, 6 pages, shame on both of us. We just have not done our work properly, okay? And I tell you what it could be a function of. Adam and I were discussing this morning. I've done startups on stores where the windows haven't been installed. I did a startup on a store where the whole side of the store, there was no cinder block. I'm looking at the parking lot. right? No bullshit, true story, okay? Right, how in God's name are you going to get a store started up? Well, we were able to get the store started up, but do you think any of the settings in anything, in any of the responses are going to be realistic? Absolutely not. So what you should always do with Microthermo, especially if you run into a situation like that, is come back 30 days later, come back 60 days later, come back 90 days later, virtually, you don't have to go to the store, and run through the reports and see which cases or coolers are acting up. It'll tell you. If you guessed wrong and your base value is a BS for one of the coolers, it's going to warn you. Base value needs to be readjusted, and you get to the case, you pull the graph, I'll talk about that later, and you'll say, ooh, I made a mistake. I set the base value at 20%, it really should be at 32%, okay? Microthermo was smart enough to let you know that, okay? So in some circumstances, you can't do a proper startup, so you might have to come back in, tweak it, and refine it, and clear up some of the problems that occurred during startup. Okay, but I'll get to you. A third of a page, a half of a page, no more than that. If you see pages and pages, shame on both of us. Yes, sir.
Can the base log be changed automatically? Can you set that
I don't think we've done that yet. Our engineers have the philosophy, do we want to put us all out of business and have it AI and then we don't need technicians anymore? So we want a human to interact and use a brain right now that's better than any computer that's out there and figure out what went wrong and take action. So right now it takes a human to interact, but great question. Any other questions? Okay, moving on. Whoops, I don't know why this is doing that. This is the last two reports are the most helpful reports. I call it the triage. This is the trend graph report. You can have up to 7 graphs per screen, all right? Now, you can go into a store and you can have 6 cases in a lineup, and 5 of those cases are running like a top, and one of them is just crazy and you can't figure out why. What you could do with the trend graph is you can say, okay, let me watch this for a week and see what's going on. You don't have to buy a data logger and hook anything up with extra wires and whatnot. We give you the ability to babysit this case overnight. So, or a week, or a month. Say, okay, track the valve position, track the superheat, track the temperature of the case, track the saturated suction, and guess what? You save that graph for that case, and it's going to save and aggregate all of that information for you. And then a week or 2 weeks or 3 weeks later, you open that case up, you pop open that trend graph that you saved, and guess what? You can go from real time and scroll back for the 1, the 2, the 3, or the 4 weeks and find out where the wheels fell off the wagon, okay? So you don't have to add anything onto the system to try to find the trouble. That ability is for you in trend graphs. So all of our nodes have the ability to do trend graphing. So take a look at this one I grabbed from a real store. CO2 discharge pressure, medium temp rack A, gas cooler outlet pressure, rack A, medium temp rack A, daily oil demands, and medium temp oil level switch. 0, 1 is on and off. So what do you think the technician was troubleshooting there? An oil problem on medium temp rack A, right? Now, maybe he solved it, and then all of a sudden it comes back again. It happens, right? Now, does he have to recreate this graph all over again? Nope. He just opens up the graph. It's called, you go to the icon that says load a graph. You load the graph to the screen, see what's happening now, and then, like I said, roll it back in time and see where the problem is occurring. Maybe it's the defrost that's messed up. Too much in defrost, something that's causing bad oil return, okay? So that's the trend graphs tool. Now let me talk about the Echelon network. Our network is different. There's BACnet out there, there's 485 out there. We love Echelon, and it's the true international Echelon. But I think any other of the control guys that are here today at this conference are going to tell you the same thing. If you got a BS network, expect you're going to get bad performance and bad information, okay? You can have the best controllers in the world, but if the network is bad, it's going to affect the performance. So the network quality, bad installation, you're going to have slow speed and you're going to have poor performance. You're going to have nodes that are appearing and disappearing. I can't stress that enough. Noise, stay away from high voltage, okay? And that includes 24 volts. Don't run network wiring in the same conduit with 24 volts, 120, 208, 460. Free air it, keep it by itself, okay? Some VFDs are notorious for being very dirty, okay? They put a ton of noise on the system, okay? Keep the network away from that. Isolate it with a router or repeater or a lifesaver device that we make if you have to. But keep the noise off the system. And for us, the big takeaway, please write this down. This is an Echelon Belden 8471. It's 16 gauge, non-shielded wire, minimum 6 twists per foot. The actual twists is what gets you the shield against the EMF noise. People put a shield wire in an Echelon system. It's like a big-ass antenna. It'll actually pull noise into the system. So if you're subbing out your work to a low-voltage contractor, he says, dude, I got it. I do networks for 30 years. Make sure he realizes that this is an Echelon network, not BACnet, not 485, because the cable requirements are totally different. Damn it. Okay, so our network is made of a near side or a far side or backbone, the backbone and channels. Adam and I don't necessarily agree, but my preference is a star network, okay? Give me a drawing on a cocktail napkin when we're having beers of how you install the network. I'll have somebody make a DWG of it, and we'll put that view on the machine so they can see how the network was installed. What do I mean by a star? Run your 16 gauge out to the center of the store, go north, south, east, west. Use the least amount of cable possible. And guess what? If you need to star from a star, I'm cool with that. Just make sure your drawing shows me that, and then I'll put the view on the screen so that you can always have somebody refer to it. So I prefer a star network. We can do elongated channels. We can do a bus network for industrial applications. I find the star network to be the most robust. So the backbone consists of the data logger, the Windows 10 data logger, the alarm node, which I'll talk about a little bit more, real-time clock, scheduler 1 and scheduler 2. You can have multiple alarm nodes on a Microthermo system. Why? Because we have physical relays as a mechanical backup to the computer system. So if they require 8 relays or 16 relays, you can have more than one alarm node. The cool thing about Microthermo is all of these Microthermos have to work together, these nodes. So they sync up to the data logger. If something should happen to the data logger, guess what? They sync up to the real-time clock. Truth be told, if there's a flood or a tremendous lightning spike and we smoke this data logger, as long as we didn't smoke the rest of the store is going to continue to operate without the data logger. You will lose your human-machine interface. You'll get a ton of alarms telling you you've got no comm, but the whole system is not going to go down because it's going to then synchronize to the real-time clock. If the real-time clock got smoked, guess what? All of these nodes have internal countdown clocks, and they will run off their own internal countdown clock. So that's a triple redundancy there if there's a problem. Now, some Echelon things that you need to remember. Our particular FTT10 network, we put a 53 ohm resistor on the backbone, and then on each channel, somewhere in the geographic center of the channel, we put another 53 ohm because we want the ohms to be balanced. Anywhere in the system, we don't want any lower than 53. We don't want any higher than 58, okay? You keep it within that tight window, and it'll be so fast you won't believe it. Yes, sir?
So how would you check it? Just say on RTU3, What are you looking for to make sure? Would you check for 53 ohms to make sure you're getting 53 ohms?
Okay, yeah, great question. So what you do is take your multimeter, put it on the ohm scale, and then you simply, there's an orange plug on every node. That's where your network connection is. And then just put your black and white right there, test it with the multimeter, and right there, it should be no lower than 53, no higher than 58. If you see 80, 90, or 100, that's usually a problem, maybe too much cable, maybe the channel is too long, maybe the network wire got skinned. But anywhere you touch the black and white, Trevor, in the system, it should be no lower than 53, no higher than 58. But you simply just check it right at the plug or anywhere that you have access to the network. Okay? Any other questions? Now, echelon rule of thumb. If they're simple nodes, you can have around 60 to 64 nodes for every channel. If they're compound nodes, the alarm node and the case controller, these are compound nodes. There's actually multiple boards inside of this node. We like to limit that to about 50 nodes per segment. Each segment can be roughly 1,640 feet long. So this particular example here, total of 315 nodes, 2.35 kilometers. You can make the network as big as it needs to be. We have customers in the upper Midwest. I think the supermarket's name is Woodman's. They're the biggest stores I've ever seen in my life. Some of them have 8, 12, 14 racks in one store, okay? Huge. They don't just have one aisle of yogurt, they have 4 aisles of yogurt. You know, I mean, I guess people have to bulk up where these supermarkets are. So again, their liquor store is bigger than the supermarket that I shop in, right? So you can make the echelon network as large as it needs to be or as small as it needs to be. If it's a large network, we suggest that you start the channel with a router. After the router, you can go your 1,600 feet. You can have 50 to 60 nodes. If you need to go longer, then you can add one repeater downstream. Guess what? I can go another 1,600 feet and another 50 to 60 nodes. So you can make the networks as huge as you need to be. And I promise you, if you stay with the Belden 8471 and what we've talked about today, it doesn't matter if it's a 300-foot network or a 3,000-foot network. It's going to work, and it's going to work well. Now, do you have to have a network this big? No. Some small box stores, some convenience stores that we do, everything is on the backbone, right? So if you only have 10 or 15 or 20 nodes, do you need to bring out the cannon? Absolutely not. You can put everything on the backbone if it's a small application. So microthermo networking is expandable. It can be as simple or as complicated and as large as you need it to be. I usually do a 45-minute class on networking. Can't do that now. Before I move on, any questions whatsoever on the network? Okay? So, by the way, when I say echelon, 2 things. There's echelon LAN talk, which is the protocol, and then the echelon hardwired network. So what I've been talking about is the hardwired network. Okay, we good? All right, so what you'll see, oh, I'm sorry, sir, go ahead.
On the SAR configuration, is the addressing still the same?
Oh, good question. When you're saying addressing, I think you're meaning like dip switches and things like that. Let me talk about that now. When you start Microthermo, you go on the landing page. You find the case controller or the MT700 or the gas cooler node, whatever you want to work on. Find the virtual node. You're going to open it up. You're going to go to the Install tab, and there's a button that says Install. And a cartoon character, an arm, is going to say, press the button. They're telling you to press the service pin button on the controller. So with this node here, with the MT700 nodes I'll talk about, where you can have up to 11 of them all in a train together, all you have to do is press that one button, and it automatically is going to talk to the data logger, and it's going to say, oh, you're the gas cooler node. Here's all your attributes. Here's all your set points. Here's all of your configuration parameters. It's going to download it automatically. You don't have to type it. You don't have to do any dip switches. I personally, with my old crippled hands, would never trust me to type in all of those alphanumerics because every one of these nodes has its own individual non-repeated alphanumeric identification. That's how we keep things separate in echelon world, right? So the machine does it itself. And being that we're on the subject, if it's a very simple node, it might take 5 minutes to load the configuration. If I have all of the bells and whistles turned on the case controller, it could take 15 minutes. So what we have built in Microthermo is called delayed installed. For those of you who work on Microthermo, you might have used this already. So what you do when you do delayed installed, it allows you to go to the icon, do the virtual install button, then you go to the physical node and you press the service pin button, and guess what? You'll see a very fast handshake in the lower left hand that, yep, you're on the right node and it sent the parameters, but it'll stop there. Then you can go to the next node, the next node, the next node, the next node. You could do 50 or 100 nodes in one day if the electrician has the job ready for you when you get there. Then you leave at the end of the day, and before you go back to the screen and you start the delayed install process. Overnight, Microthermo on its own is automatically going to program and upload all of that information where you're having a couple of cold beers back at the hotel or back at your house. Okay? You don't have to stand there and watch every single node load. It does it automatically. Now, let's just say that somebody was working overnight and they temporarily killed the power in aisle 12 and then said, oops, foobar, turned it back on, all right? You might miss those few nodes there, but guess what? There's going to be a report on the screen for you, and it's going to tell you that those nodes got interrupted and you got to just service pin them again. So it won't let you leave something unprogrammed. But you don't have to sit there and watch every node load. If you do the delayed install, it'll do it overnight by yourself, and then you'll get a status report. Open up the status report and see if it was successful. Okay? So here's what a backbone looks like. A basic backbone panel, you'll have your routers, you'll have your data logger, that's a Windows 7 data logger. You'll have your alarm node here. You'll have your UPC, which is also keeping the power clean. And we try to keep all of these components live as long as we want, as we can, I should say. And then you'll have at least a minimum of 1 keyboard, mouse, and monitor. Most stores that I do will at least have 1 remote station. And there's no loss in translation. Everything at the remote works exactly the same as the local unit at the rack. Works exactly the same if you pull Microthermo up on your phone. So here's the data logger. This is a Windows 10 data logger. Like I said, it's military spec, redundant hard drive, and what you should do is take a picture. The store information is going to be on there, the data logger serial number will be on there, and the version of Micro Thermo Alliance will be on there. Take a picture of that and keep it for your future reference. The very next component that's important is the echelon adapter that just simply plugs into the USB port. And then your black and white network starts right from that point. That's the beginning of your backbone right there. The very first node you should hit should be this one, the alarm node, okay? This is a compound node. Take a guess, how many nodes are actually right there? 4. This is a node. That's the real-time clock node. That's the real-time clock, scheduler 1. That's scheduler 2. And these are the mechanical relay connections that I told you about. So if all else fails, they'll go to their normally closed position and they'll alarm out to a third party. Could be security, could be the alarm company or whatever. You won't get a smart alarm, but you'll know that something went down in the store, okay? Again, I would start and stop this channel. Do not continue the network from the alarm node. This is such a critical node and so much information is going in and out of this node. This should be a drop unto itself. You know what I'm saying? I always pull this plug out of here because I don't want somebody to continue the network from that plug, so I pull it out, all right? And what we've done with all of the new nodes is we only have the ability to have one network connection. We do that for a reason. You twist both blacks together, you twist both whites together, that bonds the echelon channel, and even if the node gets fried or you unplug it, you are not going to take the rest of the network down. It'll still run even if one node gets smoked, if you install the wire correctly. Now, to get it on board, here's the tab that I was talking about. And you see the alphanumeric ID, the Neuron ID is already up there. And the install button is gray because it's already been installed. But what you do is you hit that button and an animation comes up, a finger saying time to push the button. Then you go to the physical node, you push the button, and then the configuration parameters start loading to that particular node. Again, no jumper wires, no dip switches, no addressing that you have to do. It does it itself. Also within this, while I'm at it, you can wink test the node from there. I'll try to show you that on the live system. How am I doing on time? You can test the node from there. You can get the details on the node performance from there. You can do a reset without being at the store. To take power off, you can virtually reset the node. If you have to replace the node, you can replace it with a new node right through that button right there. If you have to reload the node software, the button is right there. Or if you have to recommission it, it's right there. So everything that you need to do to the physical node, you can actually do virtually through the software node itself, okay? And you don't physically have to be at the store to do that. Now, what if you need more than one station? You can have one, you can have 4, or you can have 8. We call it a KVM, and it simply connects to the peripherals from the data logger, and then it gives you a local unit, and you can have up to 8 remote stations. Industrial applications usually use this big boy, and you're allowed to be 1,000 feet away, okay? So you use Cat5 or Cat6 cable, okay, and you go 1,000 feet away, and then you can have another keyboard, screen, and mouse, and have full access. Yes, sir.
For those KVM modules right there, where do you suggest we get those from? Because the one that I was trying to replace was a Raritan, and Raritan directed us to a third party.
No, we would like you. There's a bunch of KVMs out on the market. The ones that we sell, we've tested them and we like the performance of the KVM. Sometimes if you go to Amazon or whatever and you buy a KVM and you hook it up and you're like, dude, I see 3 of everything. I see 4 of everything. It just depends upon the quality of the KVM. NTI is the one that I've used the most, and we carry it. Again, it's not ours. We don't manufacture it, but through testing, we feel that's the most robust KVM. So we do have some Parker service centers in the United States. Worst possible case, you can get it overnighted from our Montreal office.
Okay.
Okay? Any other questions? Okay, moving on. Application of Alliance, I'll try to pick up. What time do we end? 2 o'clock? Oh, I really got to go. I'm gonna put the pedal to the metal. What we control here, we control racks, we control compressors. The bottom line, we will run the least amount of compressors needed to make temperature. Just because the rack has 7 compressors doesn't mean we're going to run all 7. If we can do it with 2 or 3, that's what we're going to do. Let me shortcut. This is the other takeaway. On the compressors, we have complete safety line monitoring. Any of the mechanical devices are going to be on their own circuit. We call it the safety line. If any one of those trips, you're going to get a visual alarm and you're going to get an email alarm to let you know that you have a safety line failure on that compressor. Then we also have a pilot light, a virtual proof of running. If the compressor is called to be on, but we don't sense it that it's pulling the right amount of current, and or it is pulling the right amount of current and it is running, okay, you get a proof of running, and I got ahead of myself. The opposite of that is the X proof. If, let's say, you have welded contacts and compressor 5 never shuts off, you're going to get an alarm telling you that you got a compressor on runaway. It's called X-proof. It's the inverse. However, Microthermo is smart enough to know, okay, if 5 is running all the time, then I will shuffle the rest of the compressors knowing that 5 is going to be running all the time. okay? It's not going to try to shut it off until the fault is fixed. Yes, sir.
Is that an option that's just, that comes standard, or is that something you have to enable?
Some people use the safety line, some people don't. We recommend that you do. It's usually a checkbox to enable safety line.
I want to say proof defaults to on, and then X proof, I think, has to get enabled. I believe, yeah.
Okay, thank you. Gas cooler or condenser control, we do that. I'm really going to move on. All types of refrigeration, all types of defrost we do, okay? HVAC, all I have to do is be echelon enabled or use our controls, and you will get a virtual representation of the HVAC unit, just like you're on the roof and you take all the panels off. What position are the dampers in? You know, stage 1 cooling, stage 2 cooling, stage 1 heat, stage 2 heat. All of that will be virtually available right through the front end. Load shed is built in. If you're in an area of the country where you have to have load shedding, that's already built in. You just have to enable it or turn it on. Anti-sweat control. In my neck of the woods, you have a lot of legacy old stores where the frames and the glass is hot all the time. It costs them about $300 to $325 per door to let it run like that. So what we do is we take the relative humidity in the store and we pulse just enough to keep those doors clear. Okay, and it's a function that's overrideable, or you can actually lock a percentage and you could say run at 40%, run at 80%. Okay, lighting, all kinds of lighting control we can do. I'm really going to speed this up. Corporate load shedding, built-in load shed is available. The cool thing we do with Microthermo for everything is we use an astronomical clock. We'll ask you for the address and the zip code of the store. That way, all of the civil sunrises and sunsets will be saved in there. So as any of the programs that have to do with the control of the store change because the day is longer and shorter, the astronomical clock is going to do that automatically for you. Okay, we do put opticals in the store just as a backup in case you get one of those midwinter days, especially in the Northeast where I'm from, and at 3:30, 4 o'clock in the afternoon, heavy overcast, you might need to bump up the lights in the store, maybe even bring the parking lots on. So the optical will work as a backup to the astronomical clock. All of our controls have the ability, out of one set of temperature probes, to do 3 types of alarm: primary alarm, secondary alarm, cumulative alarm. Here's what the window looks like, and I'm really going to move fast because I want to get to the live site. You can have set 1, which is a wide berth. You can have a separate high, low limit, and a separate alarm period. Set 2 can be tighter. You may not set the bells and whistles off in the store, and only certain people might get this alarm. And set 3, cumulative, looks at the delta between alarm 1 and alarm 2. That's usually for the food, health, and safety people. In my neck of the woods, that's really important. They got the temperature police that go around to the stores. And we even have industrial facilities that run our reports and temperature reports in booklet style, and they give it to the, I think it's the FDA that comes in, like produce facilities, places that make packaged salads, and they can use our reports as the proof of temperature control. What it does, here's what you see when you have all of the alarms enabled. You'll see a window at the top that is set 1, and a window at the bottom that is set 2. Number 1 is a wide berth. It's green. It never goes off. However, look at this alarm very carefully. All of a sudden, it turns red. It triggered. Why did it trigger? I colored the graph for you. Here's 15 minutes here. Here's 25 minutes here. Here's another 15 minutes. You know, that's maybe an hour. Long story short, it accumulates all of that alarm, and although you never triggered the main alarm, let's say this is a sushi case. You've had enough bad temperature for a long period of time. It has now sent a second alarm or a cumulative alarm to the people that need to know. Did you turn the blue lights and sirens on in the back? No, but somebody that needs to know got that temperature alarm, okay? Smart nodes, again, speeding it up. I didn't bring any of these with me, but if you're doing stores that are 7 years or older, you're going to see the MT500 nodes. All right. Here's the smart section. That's the microcomputer here. That's the microcomputer here. That's the microcomputer here. You can make that an HVAC node, a condenser node, a chiller skid node, whatever the heck you want it to be. And if that's not enough, you could break it open with the MPC tool that I told you. The takeaway I want you to know about this, it has to be powered by a 24-volt center tap transformer. We went away from that with the 700 series because it's not so easy to find center tap transformers, okay? The other takeaway that I want you to know is no matter it was the 504, 508, 512, they were limited by the horsepower for 8 universal inputs. So the comment that was always to me was, man, Charlie, I love Microthermo, but ye gods, you guys need a lot of boards. So our engineers took it to heart and redesigned the system to the MT700. How did they get its name? 4 relays, 8 relays, 12 relays. And these relays have a momentary switch, so you don't have to go back to the computer. You can rock the relay right from the board. Can I move on? Yes. MT700, the first MT700, Adam, if you'll pass this around, I took the cover off. This is our case controller. That's the first MT700 we came out with. It's all configurable through the front end. It's optimized for CO2. It does all of the refrigerants. It does a true pressure temperature superheat, and it can control the case 4 different ways. Temperature control with superheat limit. That's how every single CO2 store that I've started up is controlled. Superheat control with temperature limit, or straight superheat control, or temperature control priority, okay? So any one of those 4 ways you can set it to set up. We also have a case controller specifically for stepper valves and a case controller for pulse width valves. And we can do our own Parker pulse width valve, or we can do any other pulse width valve that's out there on the market. Okay? The 3 alarms are built in to the system, and these are customized. When you start any node up, is it a coffin case? Is it a multi-deck? Is it a freezer? You put that information in because the algorithms are going to be different depending upon what type of case you're controlling. There's 10 integration tabs at the top. It allows you to completely fine-tune the store. And I suggest that you do that. Like I said early in the class, come back 30 days, come back 60 days, tighten the store up because usually startup is not the best conditions to do that. So it allows you to completely customize, fine-tune, and it's self-learning. The MT700 nodes, the longer they run, the smarter they get. Okay? Now, let's talk about EEV. I'm just going to talk about stepper valves because of time constraints. So here's an example of what you can do. You can optimize it for the fixture. You can optimize for the valve type. You can do a base value correction. What does that mean? If you open the graph and you look at it for a month and you see the average place that that valve is 32% open, make that the base value. What that means is the valve is going to use that as home plate or benchmark, and that's what it's going to control around. It's not going to go around to 0 to 100. It doesn't need to do that, right? So you can do that. You can set a maximum percent open. Let's say the valve never goes open in refrigeration more than 68%. Dude, make that the maximum open. Don't let it go to 100. Doesn't need to. Pull down correction. If it's taking a little bit too long to come back to temperature, you can correct that. You can have a 2-minute pull down, 5-minute pull down, 7-minute pull down, whatever you need it to be, okay? Delayed opening after defrost, liquid temperature correction, pressure drop correction, flow direction. Do you know that our engineers found out if you feed the liquid on the inlet to the radius versus the axis, okay, so we talked, that's radial input, that's axial input, the valve actually performs differently. The curve, the performance curve is different. So we let you correct for that, okay? Just by checking, is it axial or radial, okay? Flow direction and ambient correction. So mechanical expansion valves are beautiful devices, but they cannot compensate if the ambient goes crazy, goes out of the envelope, okay? If the liquid temperature goes out of the envelope, that's everything that you can do with an electric controller and electric valve if you do your job properly. Bottom line, This is an actual graph, and I'll show you a graph so you know that I'm not BSing you. But if we do a store properly, that's what your temperature control graph should look like. If you see it's all over the place, again, shame on you and me. We just didn't do our job properly. You should get flat line control. It should spike up in defrost. This is CO2, and when you come out of defrost, it drops like a rock. Now, take my word for it, you probably can't see. This gray square right here, that's the defrost window. You want to make sure that your defrost is happening inside of that window. If you see this graph is getting lazy and that green line is getting outside of that gray window, you need to go in and you need to correct the pull down to get it down to temperature faster, okay? The bottom line is your customers spend good money to have electronic computer control. Let's just do the due diligence and tweak it, so that's the type of graphs that you'll see, okay? A word of caution, is it the controller or is it the stepper valve? Make sure that when you're doing a electronic store, you have a multimeter and you have an SMA 12 for the stepper valves. I'll say 90% of our valves are either 75 ohms or 100 ohms at room temperature. Okay, if the temperature gets warmer or colder, it changes slightly, but you want to check black to white and you want to check red to green. They should be within 5% of each other. So if black and white is 98 ohms and green and red is 101, that's within 5%. You're good to go. It's a nominal 100 ohm motor. Also, what you do, check black to earth ground, check white to earth ground, check green to earth ground, red to earth ground. If you get continuity, take the valve out, it's grounded to earth, okay? And guess what? It could be just a little skin on the wire and refrigerant will conduct electricity, okay? The other thing you should have is an SMA 12. Black to black, green to green, red to red, white to white. Put it to 200 steps per second and rock that valve open and close. Listen to it. You should hear the transmission in there humming. It should not sound like a bucket of bolts, okay? All right? And when you rock it all the way open, you should hear a gentle ratcheting. And when you rock it all the way closed, you should hear a gentle ratcheting. Okay? If you never hear it ratcheting, that might mean maybe the lead screw is stripped and the motor's turning, but the pin is not going in and out. So they're DC motors, but they're polyphase DC. That's how we get them to spin clockwise or counterclockwise. Okay? I'll fast track through this. I'll just say we've got a bunch of different nodes. They all have to start out. Any train starts with the MT722F brain. It's so powerful, the brain now, we can have a train of up to 11 nodes. But guess what? Now it's not 11 different boards. That means I don't have to drop 11 different power connections, 11 different network connections, and I don't have to service pin 11 different times. Now, I drop one time, press the service pin one time, and I've just brought that entire train online and sent all the configuration parameters to that. So less hardware, less cost, less time to get the store started up. So where can they be used? Rack controllers, circuit controllers, gas cooler controllers, and case controllers. Now, I do want to slow down a little bit. We've been talking about the valves. I'm going to try to do a rusty on this and make it real simple, right? 99 times out of 100, okay, that's a condenser, that's a receiver. When CO2 gets above 87.7, let's call it 88, it gets past the critical point. It becomes a supercritical fluid. What do we need to do? We need to have a pressure drop across the gas cooler valve, okay? Or what do they call it, Brett? The high pressure valve? Okay, yeah, I call it the gas cooler valve, but in the trade they're calling it HPV, okay? What we're doing there, when it's transcritical, I don't care if my gas cooler had 100 fans on it. We're not going to get that supercritical CO2 back to liquid CO2. We've got to get it to change phase. We've got to get it to condense. What we do is we keep the receiver slash flash tank, we keep that under the influence of the suction of medium temp, okay? That's the first thing we do. And we set that pressure. We say, we want this pressure in this tank to be 480 pounds, okay? At the same time, think of the gas cooler valve or the HPV valve as a massive expansion valve. I'm taking a lot of flow and I'm forcing it through a tiny port. What happens? Pressure drop. That drop in pressure is what gets the phase change, gets me from a supercritical fluid back to 100% liquid CO2. That's the magic. Everything else in the CO2 system is exactly the same as any other refrigeration system you've worked on. The pressures are higher, yes. You got to respect that. But other than that, that's where the magic happens right there. And I know that's the Reader's Digest version, but making it real simple. It's a condenser, it's a receiver. It's a gas cooler and a flash tank only when the CO2 goes past 88 degrees and becomes a supercritical fluid. So pressure drop across the high pressure valve, and then we're constantly keeping the flash tank, okay, around 450 to 500 pounds. What's the temperature of the CO2 coming down to, pressure coming down to drop lake? 800 pounds, 900 pounds. By the time we get through the gas cooler valve, it's now down to 450, 475, 485. And I have subcooled liquid CO2 that I can feed to the cases in the store and do my refrigeration. Any vapor that I didn't get to change phase is just vacuumed out to the medium temp rack and reprocessed, okay? As simple as that. I think my Sporlan guy talked about this, but there's the gas cooler valves, the flash gas valves. On some small systems, I've seen manufacturers actually use an SDR valve in place of the FGB. If it's like an Aldi or a Lidl where you don't have a real big load going through the valve, you can use valves offline, okay? Here's the control tabs. I'll talk about this real quick. You set it up. What am I doing? Gas cooler outlet. What am I doing? I'm doing floating. What's my approach? 10 degrees in this instance. This is just an example. What's my minimum temperature? 46. What's my maximum temperature? 80. What's my fixed set point in case my outside air goes offline? You put that parameter in this case 60. What is my alternative set point if my condenser outlet temperature fails? I put in a default value of 65. And anywhere in Microthermo, if you see a question mark, click on that question mark. A whole dictionary is going to pop up. It's going to tell you what that node does and what all those set points do. You don't have to go to a catalog to find it. It's right there. So we have the control tab, the PID, the staging, and the pressure limit. And then we have a 2-valve controller, which some manufacturers use in place of the gas cooler train. And now, you know what? I'm going to leave this up here for now. I'm going to escape from this, and I'm going to go to the live site. And I'm sorry that I had to motor through that so fast, guys. Okay. I'll put that back up so you can... Okay, so what I've done is I've connected to a site in Grand Rapids, Michigan, Gordon's Food. They've given me permission to go into their store. If we go a few minutes extra, I hope you'll stay with me. We got an alarm. Why don't we acknowledge it? So there it is. I'm going to hit right here. I'm going to acknowledge this alarm. Okay. And you see how that's red right there? That icon's got red. You notice what it did? It automatically took me to the lighting page. Okay, yep. I've told them a million times, please go up and fix this. But it's good. So I can't configure it, but right now that's how I would acknowledge that alarm. I would open up the window and I would acknowledge that alarm. Okay, now being that we were talking about those gas cooler valves, let me go right to refrigeration. And let me go to rack A. And now you may have to squint a little bit, but this is an LMP CO2 rack here. So here's the gas cooler. Look at my cursor. It's running, the fans are running at 88%. I'm not using the water right now, so the valve is closed. The set point for the outlet is 65, and my actual temperature right now is 62.9 coming out of the gas cooler. I come down through a heat exchanger, and here's my drop leg. My drop leg, take my word for it, is 869.5 pounds. 63.5 degrees. And there's my throttle valve, the LMP calls it, or the high pressure valve, or I call it the gas cooler valve. It's right now 20% open, all right? They decided they wanted to have backup valves. So they have redundant flash gas valves and they have redundant gas cooler valves. Now here's my flash tank. And although my drop leg is 862 pounds because of the pressure drop I took across the valve, right now my flash tank is at 480 pounds. Now, where is that coming from? Here's something that is a little shortcut. Right click, hit highlight connection. Look very carefully. You see that right there? I'm going to zoom in. That is turned purple. That's telling you that that is the node that's controlling or reading that point. Okay? Now I'm going to zoom out, and I'm going to right-click on that again, and I'm going to hit Cancel Highlight. Now, for the sake of argument, let me go back to that node again. Let me right-click on that and put Highlight Connections, and I'm going to zoom out. Bang. Anything that's associated with that node, anything that's being monitored by that node, anything that's controlled by that node, any point that's emanating to and from that node turns up purple. So if you're troubleshooting a system and you want to see what device is being controlled by what node, just remember, go to the node, go to the point, right-click it, and do highlight connections. And to get rid of the connection, you just zoom in again. Okay, zoom in, and then right-click, and then cancel the highlight.
Does that highlight option work on the 500 boards too, or is that?
Sure does. Sure does, yeah. We've been doing that for 27 years, okay? A lot of people don't know about that. I had a guy tell me yesterday, I've been doing Microthermo for the longest time, and I never knew about the pink tool. So that's there for you. Now, what else can you use? You see this store is big enough. It has routers. Let me take a look at this router here. I'll right-click on it. I'll do Highlight Connections, and I'll do all of the cases that are on the far side of the router. Boom. If I want to troubleshoot the network, that's how I troubleshoot it right there. All of those nodes are on their own communication channel. And I could do it vice versa. I could go to the node, right-click it, and find out what router it's connected to. So that's just called highlight connections.
So it's basically telling you almost like what comm loop you're on.
Absolutely. Absolutely. Now, I boasted about our case control. Let me show you the real deal. Whatever comes up, comes up. These are me cases right here. It's a 3 lineup. You got 38.2, 36.2, 35.3. Let me left click on this me case right here. And let's see how it's performing. Okay, I'm going to go to the graph tabs. Here's all of the different tabs. We don't have time to go through them, so let me go to the graphs tabs. No BS.
Looks good.
All right? When I got into this business almost 40 years ago, this is the type of control I used to dream about for industrial. Now you can do this type of control for your neighborhood supermarket. Now that's temperature control. Now, for the sake of argument, let's see what the superheat's been doing. Superheat is stable. The only time it changes is before or after defrost, but let me zoom in right here. Good question. I said it in the class yesterday. It was painful for me to learn as an old Sporlan guy because I was taught low temp should be 2 to 4 degrees of superheat, medium temp should be yada, 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 right? With CO2, because, Brett, it's temperature control with superheat backup, you're going to see much higher superheat because it's...
Because you're in medium temp cases satisfying with no APR.
Yeah.
So you have to shut down. Okay,
Yep.
gotcha.
Right, I do all my modulation right through the EEV, okay?
Yeah.
All right. So let's just see what is the valve position been. Again, stable. Why have that valve hunting all over the place? If fixed right there, it's perfect. The superheat is good. The temperature is good. Why have it all over the place? So now that's a zoomed in view. I know I'm going fast, guys. I apologize. Let me look for 4 days here. 4 days here. The maximum probably after defrost is 100. The minimum when it's closed is obviously 0. And the average has been 18.9%. Okay? Now if I go to control and I go to the valve, you see they have the base value at 30%, and they're allowing it to operate within a range of 2 times the base value of 30, so it won't go any more open than 60% when it's in regular refrigeration. That's how we get those lines to be linear like that. Now, because it's temperature control with superheat limit, let me look at superheat, okay? We do it a little bit, we do the superheat as a safety. We have a cutoff of 6.3, so the moment that case goes to 6.2, we're gonna close that valve. But, so we don't overshoot, we have a band of 8 for a total of 14. So what's happening is once that gets below the band, it's actually going to start feathering the brakes on the case controller. You'll see a little speedometer comes up in the process window, and we slow the PID down automatically so we don't overshoot our target points. But check it out. So we have a valve, we got a superheat, we got a pull down, we got a temperature control, we've got an environmental tab, we got a defrost tab, yada, 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 yada. But again, that's why we're able to get graphs that look like that. There's an upgrade to get a case with case control and electronics, right? So let's do our work together and make sure that when we do a store 60 days or 90 days later, that's what it looks like. It should not be all over the place. Now, let me show you a couple of other tools before we wrap up. Where do you go to get those reports? Look up here, guys, events. So acknowledged events is right here. And then you set the window and you just print right to the screen. And then the report that I always run when I get to the store is acknowledged event statistics. And then, you know what, let me go back to the first of the year. And let's print it to the screen. And what do we have? A third of a page, okay? And the problem has been, yes, they had a problem with the olive bar at that store, okay? And you see it was a bad problem because it caused a lot of hours of alarms or whatnot. But let's take a look at that store now that they did their due diligence and worked on that case. Let's take a look at the last month and print a screen.
5 years. How far back can you go?
I can go 5 years.
5 years.
Right? That's what I mean. Again, it's not that we're trying to be the police, you know what I mean, or Big Brother, but we're trying to give you the ability, because you know what? When did it start? I don't know, but the ice cream is running down aisle 5. Okay, great. So now you can go back in and you can find out when things were broken. The other thing you can do is on network. Nope, I got to completely close out of here. On network, we go to the analyzer. We've got an analyzer which will fully analyze the network, or this one here, test all routers and repeaters. This will test every single node in the store, every router in the store, every repeater in the store, or you could do it individually. Let's say, let me test router 3, and I just put test the node. It doesn't take that long. Boom, test OK.
Is there any way where we can see the amount of errors?
Yeah, I don't know if I'll have time to go in that screen. Brett asked a great question. You can actually go within the node itself and node statistics, and it'll tell you the amount of errors that particular node had. You can drill down in the network as deep as you want it to go. The other thing you can do is you can do test the network quality. And there's a 5-minute test and a 10-minute test. It'll test every node. It'll test all of the connections. It'll test the network in itself. And what you're looking for is a value less than 10. The closer you can get to 0, the tighter the information, the tighter the network is, okay? So that's the network quality test. And lastly, if you want some more information besides the tool where the nodes turn purple, if you go to network and you go to architecture right here, now what you can do is you can take a look. Here's the backbone. Here's router number 1. Here's router number 1 cases. and all of the cases exactly how it appears in that lineup network-wise. Here's router number 2, and I'll explode router number 2 cases, and there's all the cases as they are wired in that network. So I have everything as far as the complete architectural of the installed network on that job. And I think that's about time. Yes, sir, question?
Check the defrost schedule for all the circuits.
Let me see if we can get to that. So let me go into rack A. Let me go into the circuit controller. Question was checking the defrost. So I went back to the rack. I went to the circuit controller. I'll get to you real quick, Trevor. And then, now the internet's going to slow me down here. Come on. If this opens up for me, there'll be a tab for defrost, and I can show you the complete, there we go, defrost. And there it is. Now, if I hold over here, all of the attributes for the defrost come up. You see the pop-up there. Or check this out. I can grab this defrost right here, and I can move it to the left or to the right, and I can actually change the defrost. And we give you a graph, a Mason-Dixon line, so to speak. Try to make sure that all of your defrost, it's different for every store, but so you don't have too many cases in defrost at the same time, and then that analyzes the defrost, and you want to keep as much of the store below that line as you can. Trevor, your question.
So earlier you said that the controllers will get smarter as
Yes.
things go. So if you're running into issues for like the base log, how do you reset the trend so it'll start a new trend?
Okay, I don't have time to go into that, but you can open the node, and for the different nodes, for instance, the case controller, there's a button when you go into the advanced view. What Trevor, I think I'm understanding, if you have to maybe change hardware or change greatly the PID in that, and you want to reset the learning, there's actually a button that says reset the learning, and then you can start it learning from all of your corrections and not have the old stuff that was no good. That'll be gone, and you can, now that you've corrected, it will start a new history and get smarter from that point of correction. So that is in there. It's in the advanced view. Yes, sir. I'm sorry.
How often does MT Alliance back the program up?
Say one more time.
How often does it back up its own backup?
Adam, do you remember how often the automatic backup is?
Well, so they're usually configured to automatically back up every time the computer is rebooted, but they can be set up to do an automatic as well, but that's...
You can force it back like you think?
Oh, yes.
Yeah, if you close Alliance, it's right there on the desktop. There's a backup, and it's really simple. It just saves the file, and you're done.
And my advice to you, just in case, is do backups frequently, and then just like you can take a file out of Windows, you can take that backup and you can make a copy of it and you can put it on a USB drive, your latest and greatest backup. Let's say something happened to that data logger and you have to replace it. Now you've got the backup in a fire safe. You put it into the new data logger that we ship to you overnight, and depending upon how big the store is, in anywhere from maybe 2 hours to 6 hours, you can rebuild that whole system for the backup that you have on that USB drive.
Thank you.
Any other questions? Hey guys, I appreciate you putting up with me. I had to motor on through there. I'll give you my card if you want it. I'm available to do classes. I can do them virtually, or we can get enough technicians together, I can do them at your shop. It's been my pleasure